Alright, welcome back everybody to this lecture series. In this lesson, we'll be treating basic two-dimensional plots. So we'll see some how to plot, why we need plots, and some trigonometric plots, how to plot that, figures, graphs, etc. Right. So let me open up this is the command history, command window. Right. So in MATLAB, not in MATLAB, in engineering and in sciences, we need plots for um, visualizing our signals, visualizing trajectories, motion, forces, lab data, etc. So the values for a two-dimensional plot will be in two vectors. One that will hold the values of your on the horizontal or x-axis, and the other that will hold the values for your vertical or y-axis. So let's say we have a vector of 1 through 10, another one 1 through 10 as well. Right. So to plot these two, x on the x, y on the y, we use the plot function. Now the plot function can be called in a number of ways. So plot is an inbuilt function that is used for plotting. So this MATLAB function creates a two-dimensional line plot of the data in y versus the corresponding values in x. And note that the two vectors must be of the same length. You can't have one having you can't have them having an even number of elements. So plot x and y. So you pass in the first argument you're going to pass in is the um, a vector on your that will go on your horizontal or x-axis, and the second will be the ones that will go on your vertical axis. So you can also call it and specify the line, the styling of the line, right? So if you want the line to have to be different than the default, you'll see the default. We can specify um the format, the styling you want. You can also call it. We can also plot multiple graphs on the same figure. You can have multiple graphs in the same figure. So you can pass in x1 and y1. So you pass in the different x and y pairs, x1, y1, x2, y2, x3, y3, etc. as many as you want. Then you can also specify each line as you wish. You want to differentiate the different lines from each other. One may be red, one may be blue. So you can also pass in just the y values, and then the x will be generated automatically. By default, it's just going to, the x will go 1, 2, 3, 4, as many will have as many as many elements as your y has. That's if you only pass in the y, and you can also specify the format of the line as well. So let's see an example using the x and y that we've created. So x and y. So what's going to happen is it's going to create a figure window for plotting the graph. So let's do this. Because x and y are both 1 to 10, we're going to have a straight line graph with a positive slope. So it's created the figure window, and this is our graph. X on the x-axis, y on the y-axis, and our straight line graph. So if we change the y, so let's say 10 going downward, now our slope will be negative and it will be going this way. Right. You can also specify, let's say we had different numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we plot x and y. Right, so this is what it's going to look like. This is our y plotted against x. Okay. So the figure window that is created by default is figure 1. You can create multiple figures to hold different graphs using the figure function. So the figure function will create a figure window. So this MATLAB function creates a new figure window using the default property value. So you just call it using the number of the figure you want. So if I can create figure 2 by just passing in 2. So it created figure 2 here, and you can see there's nothing on it, it's a blank window. Here figure 1 holds this graph. Figure 2 doesn't have anything. So I can plot on figure 2 1 through 10, 1 through 10. And then it will be plotted here. Right. You can can call figure, can create figure 3, and to create a blank window, figure 3. Right. So what the figure function does, it also focuses on a particular figure. So I can go back and focus back on figure 1, on figure 2, sorry, or figure 1. Right. So whatever argument you pass in, it goes and focuses on that figure. If you create a figure that has not been created, if you call a figure that has not been created, that it doesn't yet exist, it will then create that figure for you. So let's try a trigonometric plot function. Let's say you want sine x. So we know that x contains the numbers 1 through 10. Now if I call sine x, I'm going to get the sine of each number from 1 to 10. Sine of 1, sine of 2, sine 3, sine 4, sine 5, sine 6, sine 7, sine 8, sine 9, sine 10. So this y now contains the sine of each element that was in the vector x. Right, so we plot this now. Let's do this on figure 2. So it's going to give me a rough sine plot. And you can see it's very rough because we only have 10 values, 10 data points. If we increase the number of data points, we'll have a smoother graph. So let's do that. So let's say our x, we have 1 through 10. But let's increase the number of data points by making the interval much smaller than 1. Let's go 0.01. And y now the sine of x. And let's use the length function to see how many elements we have in both these vectors, 901. So we've gone from 10 data points to 901 data points. We call the plot function now. Our plots will look a lot smoother than this. See, as updated. Now you can see we're plotting 901 data points now. That's why our plot is smoother. Let's try a cosine plot. G is equal to cos x. Let's go to figure 3 and plot x and g. So we'll have a cosine plot here. Right, so this is cos and this is sine. Right, so one thing you can do is on the figure window, on the graph, you can use the toolbar to navigate and explore your graph. Or you have here for restoring the view, you can use this option to pan. So if you click on this, you'll be able to move your graph around. You did this, you click this one, you can zoom in on any particular area you want. Can you click on this one to be able to zoom out, be able to zoom out, and then you can click on this to restore the view to make the entire plot fit in the window. This one is for I can't recall. This one is for brush. This one is a brush. Come. Right, so these are data tips. This is a brush, the brush data, and this is to export your image, your graph, so you can export it as an image to save on your computer. So let's try the tan plot. Let's try tan. So plot x tan x. Right, so this is the tan plot. You can see the asymptotes here, positive and negative, different asymptotes. If we didn't have as many data points, this would look very, very rough. 1 to 10, tan 1 to 10. So this is the same tan plot. This is the same tan plot as this, but this one has a lot less data points than this one does. So the more data points you have, the smoother your graph appears because you have more points to plot. Right. So in the next lesson we will look at. Okay, one more thing. Let's try one more function. Let's say you had something like h equals 3 times x plus plus x, right? So we can plot this now. So if you had any trigonometric function, you just specify what your x values would be, and then you write out the function, and then you'll be able to plot it out. Okay. And as I said, we can specify the format of the line, the way we want the line to look, and we'll look at that in the next lesson. So yeah.